Ever think about how the battery in your smartphone, might be connected to those old cassette tapes, the ones we used to listen to?
Yeah, it's kind of a trip, isn't it?
Totally. So today, we're doing a deep dive into the world of lithium-ion batteries.
Right on.
And we've got some really cool excerpts from Professor J. Christopher Wethland's work on batteries.
Batteries.pdf, yeah. It's a great read.
Definitely. It's a fascinating journey, from this unexpected origin to the tech that basically powers our entire world today. It's pretty mind-blowing.
Absolutely. It's like, classic innovation story, how something that seemed outdated paved the way for something completely revolutionary.
Okay, so let's unpack this. The paper dives into why lithium is so important, crucial for batteries.
Right.
Can you break that down for us?
Sure. Lithium is kind of like the superstar of the battery world, and for a few good reasons.
Oh.
It's unbelievably light.
Like super light.
Yeah, like seriously light. It's the lightest metal on the whole periodic table. But here's the thing, it's also a total powerhouse when it comes to storing and releasing energy.
Oh, okay.
And that's all thanks to its high electrochemical potential.
Electrochemical what now?
Yeah, it's a mouthful.
Right.
Basically, it means lithium is really, really good at moving those electrons around.
So it's like you get a ton of energy packed into this tiny, light package.
Exactly.
Makes sense, especially for things like our smartphones. But, lithium batteries weren't invented in the 90s, right?
No, you're right. They were around before that.
So what changed? What happened in the 90s?
They existed, but they weren't as, widespread or powerful as they are now. It was really Sony's innovation back then that kind of launched lithium-ion batteries into the mainstream.
Uh-huh. And this is where the cassette tape connection comes in, right?
You got it.
Okay, tell me more about that.
Well, as CDs started to become more popular, replacing cassette tapes.
Those were the days.
Right. So Sony had all this equipment from making cassette tapes just sitting around. But instead of just tossing it all out, they got creative.
Good for them.
They realized they could adapt this machinery to actually produce lithium-ion batteries. Pretty ingenious.
So they basically took these machines that used to make mixtapes and turned them into battery factories.
Yeah, essentially.
That's amazing. But how did that actually work?
Well, think of it like this. Imagine a machine that's really good at applying a thin, even coating onto a long strip of material.
Okay, I'm picturing it.
Now, in cassette tapes, that coating was made of magnetic particles, right, for recording sound. Well, Sony figured out how to use that same process, but instead of magnetic particles, they coated the strip with special lithium compounds.
Oh, so that's how they store and release energy.
Exactly.
That's really clever. So they kind of repurposed the tech. But what about the science behind the battery itself? Who are the brains behind that?
Well, there were two scientists who were absolutely essential to this whole breakthrough. First, you have American chemist John B. Goodenough, who came up with the LiCoO2 battery cathode.
Lico what?
LiCoO2, it's a mouthful, but basically it's a lithium cobalt oxide material. And then you have French scientist Rachid Yazami, who really pioneered the graphite anode. And those are the two key components, that make a battery actually function.
Now, I got to ask, when you say cathodes and anodes, what exactly are those and why are they so important?
Okay, so think of a battery like a small container, right? It's holding energy.
All right, a little energy container.
So the cathode is like the positive terminal where the lithium ions hang out when the battery is fully charged.
Okay.
But when you use the battery, those lithium ions flow through a special chemical medium called an electrolyte to the anode, which is the negative terminal. And it's that flow of ions that actually creates an electrical current, which, powers your device. The graphite anode that Yazami developed was like a total game changer because it was super stable and really efficient at receiving those lithium ions.
So Sony, combined this brilliant science with their existing technology.
Yeah, they did.
That's incredible. What did all that mean for the electronics industry?
Well, this ingenuity wasn't just like a cool trick. It seriously cut down production costs, which made lithium-ion batteries way more affordable and really accelerated their use in all kinds of devices. It's crazy to think that if they hadn't figured this out, our tech world might look completely different today.
Yeah, no kidding. That whole cassette tape thing is just wild. But how did we go from those early lithium-ion batteries to the ones in our smartphones today? The slim, powerful LiPo batteries.
Oh, that's another amazing leap forward in battery technology. In 1997, the lithium-ion battery got a serious makeover.
A makeover?
Yeah. With the introduction of the lithium-ion polymer battery, or LiPo battery. So instead of those, like, clunky metal casings, they started using lightweight, flexible polymer pouches.
Uh-huh. So that's how our smartphones and gadgets can be so slim and sleek.
Exactly.
But LiPo batteries aren't just in our phones, are they?
Right, because they're flexible, you can mold them into different shapes. So they're used in tons of devices, laptops, tablets, power tools, and even some electric vehicles.
Okay, so from cassette tapes to powering, like, cars. Wow. That brings us to the next big step in this whole evolution of electric cars.
Mm.
How did lithium-ion batteries make that jump, to that scale?
Well, Tesla's been a big force in pushing the limits of lithium-ion batteries for electric vehicles. They've really been focused on scaling up production and like squeezing as much energy as possible out of these batteries.
Yeah, I've heard those Tesla battery packs are, like, insanely powerful.
Oh, they are. They're impressive.
Can you tell us about them?
Well, they're designed to give those cars incredible power and range. And the crazy thing is, these packs are made up of thousands of individual lithium-ion cells, all wired together in this super intricate way.
Wow, that's crazy.
Yeah, it really is. They're meticulously designed to balance power, range, and, how long they last. Each cell is monitored by a sophisticated system to make sure everything is running smoothly and safely.
So we've gone from cassette tapes to powering cars. It's a pretty incredible journey.
It is.
What would you say is, like, the biggest takeaway from this lithium-ion battery story?
I think it shows the power of human ingenuity,
Yeah.
and how things that seem totally unrelated can come together to create these groundbreaking innovations.
Totally. What started as this clever way to repurpose old equipment turned into a revolution in how we use electronics and how we get around.
Exactly.
It really makes you wonder, like, what's next? Given how fast things have been changing, what might future batteries look like?
Yeah, who knows what they'll come up with.
Yeah. And how will they shape our world? It's pretty exciting to think about.
Definitely food for thought.
Absolutely. Thanks for joining us on this deep dive. It's been fascinating.
My pleasure. Anytime.